Hello and welcome. A new case in linear programming solution by graphical method. One more case on minimization, but this time we have a minimization case with less than or equal to signs. As I had told earlier, it is not necessary to have all greater than or equal to signs in case of minimization or less than or equal to sign in case of maximization. It is not at all compulsory. Yes, this is the proof. Okay, what is the case? Minimize z equals to minus x1 plus 2x3 subject to x1 and x2 both non-negative, minus x1 plus 3x2 less than or equal to 10. Yes, x1 has sign of negativity. Be careful. x1 plus x2 less than or equal to 6, x1 minus x2 less than or equal to, it is not 6, I have written it wrong, it is 2. Yes. Very sorry for this mistake. I have already rectified it. Yes, segregation of the constraint into two parts, equality to draw a straight line, inequality to get the feasible region. Minus x1 plus 3x2 equals to 10. Let's have the box having two values, showing two values to draw the straight line. If x1 is 0, then it is 10 by 3 or 3 and 1/3. Value of x2 becomes 3 and 1/3. If x2 is 0, then it is minus x1 equals to 10, so x1 equals to minus 10. Now inequality part, minus x1 plus 3x2 less than 10. If x1 is 0, then 3x2 less than 10, so x2 less than 3 and 1/3. 10 by 3 is 3 and 1/3 mixed fraction. If x2 takes value 0, then minus x1 less than 10, so minus 10 less than x, that is x greater than minus 10. Be careful and learn this step very carefully and try to remember, try to be clear in this kind of situation when there is any one or all the variables are negative in any constraint. Because of these kind of things, I prefer to show the segregation very clearly every time. Yeah. x1 plus x2 equals to 6. I think we are facing this similar kind of inequality second or third time. 0, 0, both are 6. x1 plus x2 less than 6. If x1 equals to 0, then x2 is less than 6. If x2 is 0, then x1 is less than 6. In the case of this inequality, x1 minus x2 less than or equal to 2. Again, x2 is with negative sign, so we need to be very careful. Yes, if x1 is 0, it is minus x2 equals to 2, so x2 equals to minus 2. Okay? Yeah. If x2 is 0, then x1 equals to 2. Now, inequality part, x1 minus x2 less than 2. If x1 takes value 0, then minus x2 will be less than 2. Yes, then minus 2 will be less than x2, so x2 greater than minus 2. Okay. If x2 takes value 0, then x1 less than 2. Okay, we have segregated all the three inequalities into equality and inequality parts. These two we don't need to segregate because the x1 and x2 axes in the first quadrants are showing the graph of these two inequalities. Now the lowest value on x1 is minus 10, so very large left hand side part will be there on the graph paper, and highest value is 6, so span is very large, particularly of x-axis. I will need approximately the whole board and I have to rub all this. So please write this carefully. And lowest value on x2 is -2. Yes, okay. That will appear below the x-axis, and highest is 6. Okay. I'm going to rub all of these. We are going to take the scale of scale of 1.1 centimeter equals to 1 unit, 1.2 centimeter equals to 1 unit, because there is a fractional value 3 and 1/3, yeah, in case of x2. So I advise you to take scale of 1.2 centimeter equals to 1, odd kind of scale, particularly on x2 axis. Otherwise you have to take the value 3 and 1/3 on x2 axis very carefully. If you are taking 1 centimeter, that means 10 millimeter equals to 1 unit, the scale of that. I leave it to you what kind of scale you are going to take. Sorry, I need more than this place on the left hand side, so I am shifting these on right hand side. Yeah, we need to write up to -10. I am drawing only a sketch of the graph, so it is something like a rough work. You have to bear with it. On this kind of board it is not possible for me to draw a graph with accuracy, so I am drawing only sketch. Yes, on x1 axis it is up to +6. 1, 2, 3, 4, 5, 6, and up to -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, on x2 axis it is up to -2, and on the upper side it is up to +6. 1, 2, 3, 4, 5, 6. Yes, in case of first constraint, it is -10 on x1 axis and +3 and 1/3. 3 and 1/3. For me it is approximately here. For you it will be 3.3 millimeters above 3 if you have taken scale of 1 centimeter. If you have taken scale of 12 millimeters, then you have to leave 4 millimeters to get 0.3 or 1/3. Okay, yes. Yeah, it is not at all easy even to try to draw a line on this kind of glossy board. Okay, board with glossy surface has its own limitations, but we have to bear with it. Now what about inequality part? Yes, x2. Yes, x2 less than 3 and 1/3. x2 3 and 1/3, less than 3 and 1/3 means below the line. Similarly, x1 greater than -10, greater than -10 means inner side. Yes. Okay, then second is x1 plus x2 equals to 6. So both the axes point at 6. I'm sorry. First I should write the equation x minus x1 plus 3x2 equals to 10. Okay, line is of equation only. This is 10, sorry. In this case it is x1 plus x2 equals to 6, but both are less than 6. x2 less than 6, x1 less than 6, below the line or inner side. Okay, so graph shading of this is going below the line, below the line. Now the third, x1 minus x2 less than or equal to 2. Yes, x1 is 2 and x2 is minus 2. The line joining these 2 points. Okay, x1 minus x2 equals to 2. Okay, x2 greater than minus 2, upper side. Greater than minus 2 means upper side. Greater than minus 2 means minus 1, 0, 1, 2 and so on. And x1 less than 2. So inner side, x1 less than 2. So the shading of inequality part of this constraint will be on the upper side. So common region of all four. Yes, this is the common region, feasible region. Let's use the shading to highlight that part. Okay, yeah. Now how many corner points are available? Let's check. So many corner points. O, A, B, C, D. 5 corner points are there. And the coordinates of at all the corner points are O, 0, 0. Yes, A, 0 and 3 and 1/3. B, 2 and 4. C, 4 and 2. And D, 2 and 0. Okay, and as we know by virtue of the fundamental principle of the linear programming, the optimal solution lies at the corner points. Let's check. Corner point, coordinates, and value of z equals to minus x1 plus 2x3. Let's check. O, 0, 0, 0. A, 0 and 3 and 1/3. Minus into 0 plus 2 into 3 and 1/3. So 0 plus 6 and 2/3. That will be 6 and 2/3. B, 2 and 4. Minus into 2 plus 2 into 4. So minus 2 plus 8 equals to 6. C, 4 and 2. Minus into 4 plus 2 into 2. So it will be minus 4 plus 4, 0. Yes, it is 0. And at D it is 2 and 0. Minus into 2, 2 into 0. So it is minus 2 plus 0 equals to minus 2. Since the objective is minimization, the minimum value of z is minus 2, not 0. Please be careful. This is negative 2, so it is less than 0. So minimum value of objective function minus x1 plus 2 x3 is minus 2 at point D, and the coordinates are 2 and 0. So the optimal solution is x1 equals to 2, x2 equals to 0 and minimum z equals to minus 2. This is the optimal solution of this minimization problem. Okay, now this time I leave it to you to check whether all the 5, 1, 2, 3 and non-negativity, all 5 constraints are satisfied or not. Must be satisfied, then only this is optimal solution. You just check in which way the 5 constraints are satisfied. either the equality part or inequality part of the constraint must be satisfied by this optimal solution. That's it. Thank you very much.